All right, in this video, we're going to go over solving systems using tables and graphs. All right, here's your vocab. A system of equations is a set of two or more equations. Linear system, a system containing linear equations. A solution of a system is a set of values that make all of the equations true. Because remember, they have two or more, so a set of values that makes all of the equations true is a solution. An inconsistent system has no solution. A consistent system has at least one solution. An independent system has only one solution, and a dependent system has infinitely many solutions. We're going to go over these last four a little more in depth later on in the video. But there's your vocab, pause it, write them down. All right, solving a system using graphing. All right, I'm going to show you how to do these on the graphing calculators as well. All right, so it says, what is the solution to negative 3x plus 2y equals 8 and x plus 2y equals negative 8. All right, so the first thing we got to do is we need to get these solved for y. All right, we need to get these solved for y. So that way we can plug them into the graphing calculator. So negative 3x plus 2y equals 8. Add the 3x to both sides. So 2y equals 3x plus 8. Divide the whole thing by 2, so y equals 3 halves x plus 4. Right, so there's the first one. So now we have x plus 2y equals negative 8, minus x, 2y equals negative x minus 8. Divide everything by 2. Y equals negative 1 half x minus 4. All right, so there's our two equations. Now, all right, so let's graph these on the Inspire. We're going to hit Control G to bring up the input line. Then we're going to type in our function. So 3 over 2x plus 4, and then hit enter. It'll graph the first one. Then we hit Control G to bring it back up and do the same thing with this one. So negative 1 half x minus 4. And then we hit it, and we hit enter again. Now, what we can do is we can go to menu, and then we can go down to table. Oops, we can go down to table, and we can go to split screen table. And what that'll do is that'll give us a table of values for these two graphs. Now, what you do is you want to scroll through and find where both functions have the same value. And as you can see, right here, at negative 4, they both equal negative 2. Okay, so that is solving this with a table. What you do, you graph them, and then you go to menu, and then you go to table. It'll pop up the split screen table, and you go down. F1 of x is the first graph you put in. F2 of x is the second, and of course your x values are right here. You simply use the arrows to scroll up and down until you find a value where they're both identical. And at negative 4 comma negative 2, well, when x is negative 4, both these graphs have a y value of negative 2. So negative 4, negative 2 is a solution to this system. Okay, you can see that on the graph, negative 4, negative 2, and you can see it on the table that was created as well. So negative 4, negative 2 is a solution. Now let's just double check it. What we're going to do is we're going to plug negative 4, negative 2 into each of these equations. So negative 3, negative 4 plus 2, negative 2 equals 8. Negative 12 plus negative 4, actually that's positive 12, equals 8. 12 minus 4 is 8. 8 equals 8. We're good. Let's do the other one. -4 plus 2, -2 equals -8. -4 plus -4 equals -8. -8 equals -8. Check. So, -4, -2 is indeed a solution. Okay? So, how do we do this? Well, after we solve for y, here's the equation solved for y. We plugged it into the calculator and went to the table feature and looked at the table and found where both graphs had the same x value. The same y value. Okay? And they had the same y value of -2 when x was -4. So that's how you solve using a table or a graph. All right? I showed you both ways. The graph, you graph them, you look where they intersect. They intersected at -4, -2. Or you look at the table and find where the y values are the same. And in this case, at x equals -4, they both had a y value of -2. Okay? All right, now let's go back to that inconsistent, consistent, and dependent stuff. So if your lines intersect, all right, so these lines intersect right there. That means you have one solution, it's consistent because it has a solution, and it's independent because it only has one solution. Here, this is hard to see, but there's actually two lines laying on top of each other. Okay, move the arrowheads down so you can kind of see them. So these have infinitely many solutions because it's the same exact line. So any point along the line will solve both systems. It's consistent because it has a solution, and it's dependent because it has infinitely many solutions. That's what that's called. Infinitely many solutions mean you can pick any point on the line, it'll solve both of them. Now, these two lines here are parallel. And since they're parallel, they'll never cross, so they have no solution, and that makes them inconsistent. Okay? It makes them inconsistent. All right? So remember, one solution, consistent, independent. Infinitely many, consistent, dependent. No solution, it's inconsistent. All right? So without graphing, let's classify a couple systems as either inconsistent or consistent. 8y equals 4x minus 12. All right, so the first thing we want to do, we want to solve them for y, and then we're going to compare the slopes and the y-intercepts. So let's solve these for y. So we have 4y minus 2x equals 6, plus 2x plus 2x. 4y equals 2x plus 6. Divide off the 4. Y equals 1/2 x plus 3/2. All right, let's solve the other one. 8y equals 4x minus 12. Divide 8. Y equals 1/2 x minus, pull out a 4, you get 3. Pull out a 4, you get 2. All right, so here's our two graphs. Well, if we notice, the slopes are equal. Okay, this has a slope of 1/2, this has a slope of 1/2. So they're equal. This has a y value, a y-intercept of positive 3/2. This has a y value of negative 3/2, which means these are parallel lines. Which means they are parallel lines with different y-intercepts. So that means there's no solution, making it an inconsistent system. All right? So you solve them for y, and you compare the slopes and the y-intercepts. Since our slopes were the same, that means the lines are parallel. Since our y-intercepts are different, that means it's not the same line. They are different lines, and they're parallel, so they'll never cross, and it makes it an inconsistent system. All right, they'll never cross, and so it makes it an inconsistent system. All right, let's look at another one. Let's look at 2x plus 3y equals 1, and 4x plus y equals negative 3. Again, solve for y. Minus the 2x, minus the 2x. 3y equals negative 2x plus 1. Divide off to 3. Y equals negative 2/3 x plus 1/3. Let's do the other one. 4x plus y equals negative 3. So y equals negative 4x minus 3. All right, our slopes are different. So we have different slopes, which means they intersect. And since they intersect, that means they have one solution. All right, and if they only have one solution, that means they're consistent. Because it's consistently that one solution, that's the only solution that'll work, and it is independent. Oops. Actually, no, I've spelled it right. Independent. All right. So, different slopes means they intersect, which means they have one solution. They're consistent because that one solution is the only thing that'll solve it, so it's consistent. And it's independent because it is solvable with only one solution. Okay. All right, so that is pretty much it for solving systems using tables and graphs. This one is more helpful with the graphing calculator because you can graph the system, look at it graphically. You can pull up the table feature and look at the table, and it's easy to tell that way where they cross. And then when you can't use a graphing calculator to determine whether it's consistent, inconsistent, independent, dependent, or inconsistent, you solve them, look at their slopes, and you look at their y-intercepts. If the slopes are different, it doesn't matter what the y-intercepts are, they're going to cross. All right. If their slopes are the same, you look at the y-intercepts. If the y-intercepts are the same, that means it's the same line, and it's consistent, dependent. If the y-intercepts are different and the slopes are the same, that means it's no solution and it's inconsistent. Okay, so just flip back to that chart that you should have wrote down. All right, so feel free to watch this video as many times as you need to. Make sure you come in tomorrow ready to work some problems. See you tomorrow.